Good morning and welcome back to Thursday's maths lesson. So we have been starting our topic of ratio this week and we are going to carry on with that today. Let's get started. So our what for today then is to compare fractions and ratios. So the last couple of days we've been looking at ratio, we've been understanding what ratio is, and we've been talking about it as fractions as well. But today we're going to kind of use both as different ways of writing things. So it is new learning practice and we are doing it so that we can compare two quantities. Okay, so what do we mean by ratio? Right, a little rewind for us. So hopefully you can remember that ratio is a part-to-part comparison. You are comparing one thing to another thing. And we use this colon here to represent ratio. So it's this part compared to this many parts. And if you add these together, you get the total number of parts that make my whole. Okay then, so this was these are the sentences that we've been using this week. For every one yellow counter, there are two red counters. Can you, in your book, after you've written today's date, can you write down what this would look like as a ratio written with the colon? Can you draw it and show me what this might look like? Okay, so I've written Y and R for yellow and red so I don't get confused. And it's one yellow counter for every two red counters. So here it is as a part-part whole model. So I've got 1 part yellow for every 2 parts red. Okay, 1 part yellow, 2 parts red. So how many counters are there in total? How many parts have I got altogether? Well, I've got 1, 2, 3 parts. So altogether, I've got 3 counters. Next one then. This time we're going to make a pie. And there are 2 green apples for every 5 raspberries. Can you write down what this would look like as a ratio? And can you tell me how many pieces of fruit make my whole? And this time, can you prove it by drawing it using a bar model, using a part-part whole model? Right, let's have a look then. So it would be 2 to 5. So we'd have A for apples, R for raspberries, 2 to 5. How many parts of fruit make my whole? Well, there's my 2 parts apple. There's my 5 parts raspberry. So if I add them all together, I would have 7 parts making the whole. Well done. Okay then, now we are moving on to what we were looking at yesterday. So can you please tell me, for every 2 cows, there are how many sheep? And when you've done that, I'd like us to take it one step further and I'd like you to write down what would this be in the simplest ratio. So this shows me then we've got 2 cows for every 4 sheep. And that's because we've got 1, 2, 3, 4, 5, 6 cows. So we've got 6 cows compared to 4, 8, 12 sheep. So we can divide it by 6. Oh, let's divide it by 3 first of all. So divide it by 3, which would be 2 cows to every 4 sheep. And hopefully you can see that because they're kind of in a row, aren't they? Like this. Look, we've got 2 cows, 4 sheep. Right, is there a simpler form, though, that we could write this in? Well, we've got 2 cows compared to 4 sheep. Can we divide those by something? Is there a common factor? Divided them both by 2, 1 to 2. It'd be 1 cow for 2 sheep. Well done if you got that right. And here's another one. So in art class, there are 2 girls for every 1 boy. If there are 6 girls in total, how many boys are there? Okay, so for this one then, I've written down the basic ratio, which was 2 girls for every 1 boy. But this time there are 6 girls. So what have I done to this ratio to get to this ratio? Well, I've multiplied it by 3. So what have I got to do to the boys? I need to times it by 3. So if there were 6 girls, there would be 3 boys. Well done if you got that right. Okay then, can we please write discover? And we're going to get started with the main part of today's lesson. So we are at football training with Mr. Lopez. And Mr. Lopez says, at football training today, for every 3 girls, there are 2 boys. Okay then, so 1A then, if there are 12 girls at football training today, how many boys are there? B, because we're starting to look at it as fractions as well, what fraction of the children at football training are girls and what fraction are boys? So, to start working this out, write down your basic ratio, make sure we label it to start off with. Then, think about if there's now 12 girls, how many boys must there be? Because that ratio has to stay the same. And then for B, we need to think about this as a fraction. So with it as a fraction, think about what's the whole, how many children are there all together. Pause the video and off we go. Answer time then. So I've started off by writing down the basic ratio. So for every 3 girls, there are 2 boys, 3 to 2. Then I know that there are 12 girls at football training today. So I've written 12 down underneath the column for girls because it told me there was 12 girls. So what have I multiplied the girls by? How many lots of this ratio have I got? Well, I've times this side by 4. So what do I need to do to the boys then? Well, what you do to one side of the ratio, you need to do to the other side of the ratio. So 2 times 4 is 8. So if there was 12 girls at camp, then there would be 8 boys. Next one then. What fraction of the children at football training are girls? Okay, so I'm going to write B. So how many girls at football training are girls? Okay, so I'm going to start with this one. I'm going to start with 12. So there's 12 girls out of how many? So I've got 12 girls and 8 boys. How many children are there all together? Well, there's 12 out of 20. So this many are girls. 12 out of 20 are girls. Can I simplify this? Well, yes, I can divide them both by 2, which would be 6 over 10. Can I simplify them again? Yes, I can divide them by 2 again, which would be 3 over 5. What do we notice? Well, hopefully you notice that this is the same look as the original ratio because we know that we can simplify fractions, simplify ratios, the same as we do for each one by using the lowest common multiple. Because look, girls would have been 3 out of 3, 4, 5, add them together, 5 parts, 3 out of 5 parts. So either of these would have been an acceptable answer. What fractions are boys then? Well, if 12 20ths are girls, that means 20 take away 12 is 8. So 8 20ths would be boys. Or 5 fifths take away 3 fifths, 2 fifths. Because these are equivalent fractions divided by 4. Well done if you got those right. Okay then, think together. For every 2 children wearing a bib, 1 child is not wearing a bib, as you can see in the photo or the picture. If 10 children are wearing a bib, how many children are not wearing one? Have a go. So first things first, write down the simplest ratio. So I've written bib and non-bib so I don't get confused. So there's 2 children wearing a bib for 1 child not wearing a bib. So the ratio is 2 to 1. If 10 children are wearing a bib, think about which side of the ratio that's going to go on. So it goes on the left-hand side because that's showing how many children are wearing a bib. What have I done to get from 2 to 10? What have I multiplied it by? Well, I've multiplied it by 5. So what am I going to have to do to the non-bib group then? Well, I have to times that group by 5 as well because I've got 5 lots of the other group. I've got 5 lots of this group. 1 times 5 is 5. So for every 10 children wearing a bib, 5 children weren't wearing a bib. Question 2 then. For every 1 triangle, there are 3 squares. So we've got a bit of a pattern going on here. So for every 1 triangle, there are 3 squares. Straight away, write down your basic ratio. If there are 5 triangles, how many squares are there? And then for B, if there are 18 squares, how many triangles are there? Pause the video and have a go. Okay, so I've written down my basic ratio. one triangle for every 3 squares. I now want 5 triangles. So I've times this side by 5. I've got 5 lots of triangles. Or 5 lots of one triangle. So now, what do I need to times this side by? I need to times this side by 5. I need 5 lots of 3 squares. 3 times 5 is 15. So if you had 5 triangles, you'd have 15 squares. Right, I'm going to write this out again. Draw my little pictures so they get confused. So the basic ratio is 1 triangle to 3 squares, even though mine looks a little bit more rectangular. So if there are 18 squares, how many triangles are there? So I write 18 here. Is that right? Hopefully you were shouting at your screen, no, that's not right, because the question said 18 squares. So let's draw it out again. If I want to find out what 18 squares would be, do I need to put the 18 on this side or this side? Well, hopefully you can tell me it'd be this side, because this is the side that's showing how many parts of the square. This is going to work out what if there was 18 triangles. So I need to make sure that I'm writing the 18 on the right side. Okay. What have I times 3 by to get to 18? How many lots of 3 make 18? That would be 6. So what am I going to times this side by? I'm going to times it by 6. So 6 triangles will be the same as 18 squares. Well done if you got that one right. That one was tricky. Okay then, it is independent practice time. So we have got 5 questions to have a go at. Number 1 then, Lee draws some squares. For every 3 squares he draws 4 circles. Here is part of the diagram Lee has drawn. Can you complete it? So for every 3 squares, you need 4 circles. And then B, how many circles has Lee, or you, drawn in total? So if you finished off the diagram, how many circles would there be in total? Number 2, a jar contains strawberry sweets and lime sweets. For every 2 strawberry sweets, there are 3 lime sweets. There are 18 lime sweets in the jar. Can you work out how many strawberry sweets there are? Now, you can use this table. However, you don't have to. If you would rather use the method that we've been doing, that is absolutely fine. Okay, so can you work out if there was 18 lime sweets, how many strawberry sweets? Okay, then here are 3, 4, and 5. So for number 3, a box contains some buttons. For every 2 white buttons, there are 5 black buttons. If there are 12 white buttons, how many black buttons are there? Number 4, in a fish tank, for every 1 clownfish, which is like a Nemo, there are 4 boxfish. If the tank contains 7 clownfish, how many boxfish are there? And number 5 is an explain it. So a pattern is made up of squares and rectangles. For every 2 squares, there are 5 rectangles. Explain why the pattern cannot have 7 squares. Answer time then. Well, for every 3 squares, Lee is drawing 4 circles. So for the first 3, he's already drawn 4. For the next 3, he needs to draw 4 more. And for the last 3, he needs to draw 4 more. So that's what your diagram should look like. How many circles has he drawn? Well, he's drawn 4, 8, 12. 12 circles. Number 2 then, and ignore the bit where I've gone wrong. So basic ratio then is 2 strawberry to 3 lime. So it's 2 to 3. I want to know how many strawberry if there's 18 lime. So make sure you've got this in the right column. So 18 lime sweets. So you've done 3 times 6 to get to 18. Times the other side by 6, it will be 12 strawberries. If you've gone wrong there, make sure you put the lime, the 18 in the right column. Okay, then here's the answers for 3 and 4. So the basic ratio for number 3 is 2 white buttons to every 5 black buttons. So I've written the ratio down. I've multiplied the white buttons by 6 to get to 12. So I multiply the other side by 6, which would then be 30. So there'll be 12 white buttons for every 30 black buttons. Number 4 then, again, I've written down C to B, which is 1 to 4. I then want to know what 7 clownfish would be. So I'm multiplying the clownfish side by 7. So I need to times the boxfish times by 7. 4 times 7 is 28. So there will be 28 boxfish in the tank. Okay then, so for this last one, if for every 2 squares, there are 5 rectangles. So your basic ratio is 2 to 5. Okay, what about if we had one more lot of each? So then we would have 4 squares to 10 rectangles. What about if we had 6 squares? Then we would have 15 rectangles. What about if we had 8 squares? Then we would have 20 rectangles. Right, why can you not have 7 squares? Well, the reason you can't have 7 squares is because 2 is not a factor of 7. You've got to keep the numbers as whole numbers, so 2 squares for every 5 rectangles. If you keep going up in groups of 2, you would not get to 7 because 2 is not in the 7 times table. So the pattern can't have 7 squares because we're going up in 2 squares every time. Really well done for today's lesson. Send me your photos on Portfolio and I'll see you tomorrow. Goodbye.